Good
evening.
Good evening, sir.
Audible, sir.
Okay. Actually, this prior 15-minute session is for uploading your assignments in the Google Drive. As many of them has facing some problems and they don't have some idea like how to upload it and how to name the assignment. So for this 15 minutes, we will be teaching one 10 minutes. We'll be teaching about how to upload assignment in a Google Drive. Okay. So Mr. Samir, are you there? Samir?
Yes, yes.
Yeah. Guys, this is
Hello.
Samir.
Am I
He is
audible?
one of our yes, you are audible. This is Samir. He is one of our admin team member, and today he will be explaining you about how to upload your assignments in a Google Drive folder. In what procedure you have to upload. Okay. And after this, if you have did any mistakes, please go and correct it and submit it. Okay. Um,
Okay.
okay.
Shall I
Samir,
start now?
you
Yes.
can take over now.
Okay.
Yes.
Is
And
my screen or visible?
Yes, sir, visible.
Yes, sir.
Okay. Okay. First, you have registered for Intern Expert using a mail ID, right? You have to open that, and some might not know where to get the shared files. You can go to the drive of the email, and then you can go to shared with me file. You can see the folder which is shared with you, and in students list you will have all your folders or students folders. I have taken a test folder to just explain you about how to do. Okay, this is a test folder. You have to you can upload in your folder either by clicking upload files, and then you can select and it will be uploaded, or else you can do like this. You can drag the file to this page and you can upload the file. Okay, now I've told you to rename all the files with the stay with OIP and the date in which the session was taken. And for that, yeah, you can right click in this and click rename. You can rename the file as OIP September 20th session. Don't put the date in which you are doing the assignment. It has to be in the date in which the session was taken. So you can do this and click OK, and the file will be changed. So your folder has to be like this. I've taken a folder from our student only, Dinesh Kumar. He has changed everything. It has to be like this neat, and it has to be like OIP and the date in which the session is taken. It will be helpful for us, and also it will be useful for your reference also. And யாருக்காவது புரியலன்னா நான் தமிழ்ல கூட சொல்றேன். Anyone need more clarification regarding this?
is there any doubt in this? And if anyone needs in Tamil, definitely we will explain it in Tamil.
Regarding
யாருக்காவது தமிழ்?
mentors report.
Hello, sir.
Yes, yes.
Okay.
Sir,
Mentors report.
explain in Hindi.
Hindi? Okay. Anthony bro இருக்காங்களா?
Hello. Yeah, I'm
Anyone
there.
any doubt?
Yeah, hello.
Okay. Folder. See, mentors folder is not shared for particular mail ID. So we have shared you one link in your WhatsApp group. I'll after this send you the link.
Hello.
So once you click that link, it will automatically go in. It will automatically go in, and you can go through it. Yes, I'll explain it in Tamil also. Mentors folder பார்த்தீங்கன்னா மென்டாஸ் ஃபோல்டர் வந்து ஓப்பன் லிங்க்ல தான் இருக்கு. பர்டிகுலரா ஒரு மெயில் ஐடி கொடுத்து நாங்க ஷேர் பண்ணல. அது ஓப்பன் வியூ ஃபார் ஆல் தான். ஸோ நாங்க வந்து இந்த செஷன் முடிஞ்ச உடனே வேணா நாங்க திருப்பி அந்த லிங்க் அனுப்புறோம். மென்டாஸ் ஃபோல்டருக்குள்ள போயிடும். உள்ள நீங்க எந்த மென்டாரோட பிபிடிஸ் நீங்க ஸ்டடி பண்ணணும்னு நினைக்கிறீங்களோ அவங்களோட மென்டார் அந்த நேம்ல நீங்க கிளிக் பண்ணிட்டு ஆட்டோமேட்டிக்கா உள்ள போயிடலாம். வேற
Hello, Arvind.
ப்ராஜெக்ட் ரிப்போர்ட்
Arvind.
எஸ் எஸ்
Arvind,
Yeah, Anthony bro.
हिंदी लो சொல்லிருவா मिस्टर दीपेंद्र. आप समझ रहे हैं ना दीपेंद्र जी?
हाँ सर
समझ गए ना?
सर इन हिंदी
ओके।
नहीं आप अच्छा नहीं आपको समझ गया नहीं समझ गया मतलब कैसे अपलोड करना है उसमें असाइनमेंट?
अपलोड करना समझ गया सर।
अच्छा ठीक है, बस इतनी है और कुछ नहीं बोलो. और मेंटर का फोल्डर है ना
about the uploading thing, Mr. Dipendra. And
हेलो सर, मेंटर में अपलोड करना है ना सर,
the project report.
मॉनिटर जो है उसमें अपलोड करना है ना?
नहीं मेंटर फोल्डर में अपलोड नहीं कर सकता यार. आप सबके लिए अलग अलग फोल्डर है, आपका नाम पे सबके लिए अलग अलग फोल्डर है, ठीक है? उसी फोल्डर में अपलोड करना, ठीक है? और मेंटर फोल्डर में क्या है, आपको सब मतलब पीडीएफ पीपीटी डॉक्यूमेंट्स सारा चीज मिल जाएगा आपको रेफरेंस के लिए, ठीक है? और व्यू कर सकता वैसे मेंटर फोल्डर जाके अलग अलग मेंटर है ना, जैसे राहुल सर है, राजेश सर है, गवाई सर है, तो ऐसा इनका
हमारा
फोल्डर पे
फोल्डर
अलग
है,
अलग
हेलो सर, हमारा जो खुद का फोल्डर है वहाँ पे वो सब सर जितने सर है उनका सबके जो नाम है वहाँ पे अपलोड करना है।
हाँ, आपका असाइनमेंट आपका फोल्डर में अपलोड करना, ठीक है? हाँ ओके.
Okay, and then regarding the project report, someone is asking in Tamil. Project report ஒன்றும் இல்லைம்மா. ஆக்சுவலாக என்னன்னா உங்களுக்கு ஒரு காமன் டிராஃப்ட் கற்றுக்கிட்ட டாபிக்ஸ் தான் வந்து அங்கே அவங்க போட்டிருப்பாங்க. கண்டென்ட் ப்ராஜெக்ட் கண்டென்ட்ல வந்து என்னென்ன டாபிக்ஸ் நீங்கள் பழகிருக்கீங்களோ அந்தந்த டாபிக்ஸ் பற்றி தான் போட்டிருப்பாங்க. ஸோ நீங்கள் ஸ்ட்ரைட்டாகவே நீங்கள் அந்த டாபிக்ஸ் நீங்கள் என்ன படிச்சிருக்கீங்களோ அதை நீங்கள் வந்து அதை ப்ரீஃப் ரிப்போர்ட்டாக எழுத போறீங்க. அதுதான் உங்கள் ப்ராஜெக்ட் ரிப்போர்ட். மேக்ஸிமம் உங்களோட ஃபைனல் இயர் ப்ராஜெக்ட்ஸுமே இப்படிதான் இருக்கும். அண்ட் உங்களோட சர்டிஃபிகேட்ஸை வந்து முன்னாடி நீங்க டேஸ்ட் பண்ணி இதை உங்க ஃபைனல் இயர் ப்ராஜெக்ட்ஸா கூட யூஸ் பண்ணிக்கலாம். ஓகே சார், லைக் டுடேஸ் ஃபார்மேட் வாஸ் ஷேர்ட் ஃபார் பாஸ்வான் சார். Actually, Pashwan sir's session doesn't have any PPTs. It's for only reference links and some Excel sheet calculations. I'll definitely tell Mr. Pashwan sir, is there any files you want to upload? Definitely will upload by tonight. Okay.
Arun, shall I start?
And all your project form by tonight. I think everyone received Pashwan sir's common format, and they have also. And by today or tomorrow, you'll be receiving the other two mentors project format also. You all start to prepare your project reports based on your mentors. You get the project report, just merge with the project report and you please submit it. You don't want to wait till the project comes. Okay, now Rahul Singoli sir is here. So, sir, shall we?
Yes. Thank you, Arvind. Very good evening to all. Arvind, my voice is getting?
Yes, sir, it is clear, sir. Let me give an intro for you, sir. So, again, good evening, one and all. This topic is based on mechanical design, CAD and CAM. So, today, our mentor is Dr. R.S. Singole. He is a managing director of Shea Innovative Technologies, Pune. He also worked in professor in Department of Mechanical Engineering in D.Y. Patil College, Arkudi, Pune, and worked as UGC approved principal in Dr. D.Y. Patil COE and Innovation Calagon, Pune. He has also completed his bachelor's degree in Mechanical Engineering and Masters in Mechanical CAD, CAM, and PhD in Mechanical Engineering. He has 18 years of teaching experience and 5 years of research in industrial experience. So it's a immense pleasure to welcome you, sir.
So thank you, Arvind, for introducing me. So very good evening to all.
Good evening, sir.
Yeah, good evening.
Good evening,
So, sir has given the introduction of me, Dr. R.S. Singole. I am associated with so many industrial organizations, nationally and internationally. I published around 115 research paper. Again, 3 books at international level, one with Springer, and all these are published from the Germany. I did around 20 patents. I'm a patent trainer also. I'm guiding the 7 PhDs in the Savitribai Phule Pune University. I am a type with around, I did MOUs around 50 companies. Guest lecture conferences around 300 I organized for the various organization for the student, faculties, and industrial peoples. Okay. So today I will give the insight about the CAD CAM and CAE industries, what exactly happened there. And initially, all of you are from the engineering background. I will give the some basic information, basic knowledge about the design also. So whatever we are going for the so many areas, like you are learning from so many days, oil and gas sector. Then automotive industries are there. Chemical refinery plants are there, manufacturing, petrochemical plants. Again, the pharmaceutics companies are there, agriculture-based companies are there. Everywhere, the design is involved. There is the importance of the design. Okay. So I will share the PPT with you all so that you will get what exactly the things are happening here. So all you are welcome to our intern expert company. So it is having the types or co-partners are there, CITEX, DAS. These are the UAE based companies. Petroleum Soft, it is the UK based company. And Infra, it is Indian based companies are there. So we have come up with some model for all the engineering students to get what exactly the internship is there. Number one. Again, by sitting at home, how you can handle the different types of projects, assignments, and departmental information. That is our aim. So whatever the matter in my PPT, it is a copyright, and some of the matter is taken from some Google sources, some of research paper, books. So today I will particularly deal with the CAD and design part. So everyone know the design is very common term. It is used everywhere. In our home application also, we are using the design so many times. Design of car, design of book, design of TV. So design of pressure cooker. Everywhere we are using this design term. And how to then define the design? So we are going for the fashion design. Fashion design also a sector there. Again, everywhere mouse, design of mouse that you are learning. So here, everything is based on the design. So design is the finding out the dimensions and the parameters by using the technical formulation. Okay. What exactly these design aspects are there? So mouse Function of mouse is to operate the laptop or computer. So we have to operate. Then there is a man-machine relationship comes, that we are operated by the hand like this. Then what will be the design? What is the shape of it? Curve one, base is around flat one. Some curves are provided to the both the side, and there is a one middle button is there that move up and down. Okay, circular fashion, that movement is there. So this part come under the design. Here it is operated by the student. It is operated by all the age group from 4 years child, 10 years, 15 years, up to the old of 80, 90 years. So it is hand design is there, hand, how the hands are there, okay, how it can be put in the hand. Okay. Again, if he is 3 years old, how he can operate it, how it can hold it. Okay. So is it feasible for that child? Again, the person who is in a computer engineering or maybe the design, so how he can operate, how it can be there. It is for the all age groups. Okay. So we tell that it is a beautifully designed. Beautiful term is somewhat a language, English language term, beautiful. Okay. So in our mechanical design or in the engineering background, we may call as aesthetically designed, aesthetic look. Okay. Aesthetic means appearance, how it looks, what is the color of it, black. Then geographics is written, that is a white color. So that is the appearance of it, okay, color wise, okay, and look wise. So that is a aesthetic. Now second term will come the ergonomics. Ergonomics is the man-machine relationship. When we are going for the man-machine relationship, so you are operating your car, you are driving your car, you are writing by your pen. So how it can be holded, your pen in your fingers, how it can be holded in your hands, how steering is you are holding by the two hands or single hand you are operating your car. Clutch brake system, your legs are coming there, clutch brake system. Maybe in the two-wheeler, clutch is there in your hand, brake is there in your right leg. So these are the things that come under the ergonomics. Ergonomics, ergon, nomos. It is a Greek word. That is the relationship between the man and machine. You are having the different types of two-wheelers with you. And suppose if you are having the any Honda model or maybe the Suzuki, Kawasaki, any model. Maybe the girls are there, they are having the scooty. XYZ two-wheeler you have purchased. Why you are purchased that particular vehicle? You need a mileage. You want to go to the college within the less time. So again, it can be used for the multiple purposes, two-wheeler. Okay. So everyone may be purchasing of a car or two-wheeler. We are looking for the mileage. We are looking for the aesthetic look, how the color is there. Somebody have taken the black and red combination, white combination, blue, and then some of you like the yellow combination. That is a look that come under the aesthetic look. So these are the things that are associated with the design. So design is a very broad concept. Then how we can fit in our mechanical design? In our industry, how we can fit it? So there may be the classification of the design. How we can classify the design. First is a rational design. What is this rational design? It is based on the determining the stress and strains on a component, on a part, or on an element, and thereby deciding their dimensions. Basically, it is depends on the mathematical formulation and some principles of the mechanics. That is called as a rational design. Whenever there is a term is come rational, and so it is based on the stress and strains, means the load is acting on the part. So I am putting the load on this mouse. Again, there is a stress and strain induced in this particular mouse. We are doing the click, right click, left click. So I am operating the load. I am operating the some Newton of force. That force may be the 0.5 Newton. Okay. If I am applying the more Newton, 10 Newton, it will break. I can apply up to the 1 Newton. So it is designed for that. You are operating your mobile. Touch screen is there. Okay. Can you force there like this, like this, like this? No. That is only the touch sense is there. But touch sense is not here. It is on the laptop. Near to the keyboard, there is a touch senses are there. This is the design. This is the design. It is called as a design. Now, second part will come the empirical design. It is based on the empirical formulas. Some thumb rules are there. Calculations are there. Okay. The size of this mouse, maybe here I can reduce here small size. 2 millimeter I can reduce here, 2 millimeter here, 2 millimeter here, so that I can save the material. That is also valid. I can increase the dimension by the 1 millimeter, 1 millimeter, 1 millimeter. So it doesn't matter anything here because it is operated by the hand. Okay. So that doesn't make a lot of difference. Same type of 1 millimeter, 2 millimeter changes if I are doing in the engine. So then it is a problematic. 2 millimeter changes I am doing in the watch, then it matters a lot because we are changing the things in the microns in the watch. If I am improving the size and shape of the mobile, so that is also matters a lot. Means if I reduce some 2 millimeter here, my cost will reduce. Increase the 2 millimeter here, my cost will increase. Okay, so these are the things. These are based on some practical experience. There are some thumb rules. Okay, so that thumb rules are also there, and there are certain design methods. Past experience, we have to design such type of products or components or elements. Okay. So why I'm telling the components or elements? Okay. So in this one, I'll have to see the speeds. So how many elements are there here? One element, second element, and a third frame. So 2i, that is this part. This is the whole one element, second element, third, and small things are there here. So these are the elements. By combining these elements, we are getting the machine. We are getting the mechanism. Now this part come under the mechanism. Okay, here what is the mechanism here? Like this. That is the mechanism. Is it possible here mechanism, same type of mechanism? Not here. Clicking mechanism is there. Click. Small force we can apply here by clicking. The mechanism is different here. The third part will come the industrial designs. This type of designs depends upon the production aspects to the manufacturing of any components of the machine. It is based on the industrial considerations, market survey, external look, production facilities, cost effectiveness. So a lot of things are there in the industrial design. I want a car. Which model I want to purchase? Maruti, Toyota, KIM, Mercedes, BMW. Which component I want? Which car I want? What are the different types of components are there? Bonnet, chassis of the car, again the engine, then the piston cylinder mechanism, steering mechanism, Seating arrangement, chairs are there, up and down movement, sitting arrangement, transmission system, gear system. So everywhere the design aspects are coming. Spring mechanism, we may call it as the shock absorber that is in the two-wheeler. Shock absorber. How exactly is absorb the shock? There is a spring mechanism is there. So how the spring is designed? What is the damper provided there for the vibrations to reduce the vibrations? So all these are the different aspects of the industrial designs. By using all these aspects, all this information, we have to go for the industrial design. Industrial design is more closer to us. Some of you are computer engineer. How you are dealing with the software based part. Again, the hardware is there, machine is there, CPU, monitor. Huh? You are getting my voice is getting properly? Any problem? Yes, somebody is unmuted, I think. Okay. So all of you are learning the various aspects of the industrial design. Okay. So what exactly the happen where we are applying this design to the industries? Just I given the example of the computer engineer is operating the Java, Oracle, IoT based some software systems, but they want to purchase the computer. So they check the configuration, they check the model, they will check the screen size, monitor size, pixel rate, how it can be comfortable to our eyes, how it can be operated smoothly. So i5, i7, i10, whatever new models are there in market, they are checking the configuration. CPU size also. So all these are the aspects that's come under the industrial design. Again, if you want to purchase the mobile, you are checking all the aspects. Also, how the Android is there. Maybe the Apple is there. iPhones are there. You are checking how the softwares are there. So can it be compatible to our normal mobile? You're checking. Why is it connected to our TV? You're checking it. So these are the some technical. These are the some details that you are checking to the software. That is one part. Secondly, when you are going for the some size and shape of the particular model, then can be fitted you properly in your hand, can be fitted in your pocket. So what is the cost of it? How the color, size, shape, you are checking everything there. So all these are the various aspects that you are coming in the mind of a customer. That is called as a market survey. When the people are giving the suggestion to the particular company, they do the changes in the mobile. They do the changes in their various models. Somebody need the model of a gray color. They will check how many people want a gray color model. Pink color, how many people want a pink color body. Color, white color, normal hair. This if batch size or mask size, then they prefer now this color were launched. Then they are the cost of phone with the Samsung.
Hello, sir. Voice is not audible.
So from my phone, everything is fine. Now you are getting my voice. Can you audible?
Yes, sir.
It's better, sir.
Yeah. Now is it fine? Is it comfortable? All of you are getting my voice? Abdul, Atif.
Yes,
Yeah.
sir.
Sir,
Yes,
it's
sir.
breaking somewhere.
Sir, now it's breaking, sir.
Voice breaking. Okay. Okay. Yeah. Voice is breaking, na?
Yes, sir.
So connectivity is proper, but voice how it is breaking? This I will check it. Everything is connectivity आहे का व्यवस्थित? So here is no problem now. Is it comfortable, all of you?
Yes, sir.
Yes, sir.
Prakash, can you tell? Is it now fine? Prakash.
Yes, sir.
So is it fine now?
Yes, sir. Audible.
Yes, sir.
Abhishek, Abhinav, are you getting my voice comfortably? Abhishek. Abel Matthew.
Yes, sir.
George, are you getting my voice? Yes.
Yes, sir.
No. Okay.
Yes, sir.
Yes. But tell me in the chat window. Reply in the chat window. Sir, it is audible now. Audible. Okay. 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 No problem. Okay. Yes, I will continue. No issue. Going for this industrial design, lot of aspects are coming there. Market survey. The market survey, you have seen the market survey, the mobile, color, costing, and n number of parameters are there. External looks. Production facility is the part of company only. Okay, they will check. Costing is checked by the company. Existing standards of the product, yes, these are obviously this with the companies only. Okay. Now here design process will come. What is the identification of need? What is the need of the customer is there? Yeah, identify the need. That why the market survey is there. Mobile survey. Just now I told you the market survey, mobile survey. Then definition of the problem. How we are defining the problem. How we can manufacture the mouse. How we can manufacture the pen. So we are having the 4 or 5 different types of solutions for the problem. We have to use the optimum solution. We have to do the analysis, everything. We have to go for the optimum. Then evaluations are there, testings are there. And lastly, the presentation. So this is the design chart, or this is the design process. There is an interrelation, so all of you to see here. All of you to see here, evaluation, some problems are there. Again, it will go to the identification of good. Evaluation, again, it will go to the definition of problem. Okay. Analysis, again, it will go to here. Again, it will go to the definition of problem. So all the departments, all the things are interrelated. They are interconnected. Okay. Then in the analysis or optimization, that is optimum solutions where to give it to the company. Then they will test it. They will evaluate it. If it is fine, they will come up with the final presentation. That is in the documentary form. So everything we have to put in a documentary form. We have to put it in some word form so that everything is get recorded. If any suggestions are there, we can do the suggestions instantly. Okay. These are the things which are associated with the design process. Okay. And these are the various phases in the design. Okay. Now all of you to do one thing. Note the what is the design. Okay. So everyone had to note the definition of design. Can you note it? Design is the, everyone please note. Design is the process of. So what happened now, while we are attending such type of internship programs, while expert is giving the talk or a knowledge, it will be remembered for the couple of days, maybe today, tomorrow, you will everything will remember design, CAD. But for the long period, for so many years, if you want to remember, you have to write it, you have to understand it, you have to grasp the concept, then only you will be comfortable. That's why writing the simple notes is very important. Okay, please everyone have to note the design. What is a design? So I will give the definition. Don't write the matter from the PPT. Okay, it is a process. Write down the what is a design. Definition of the design. It is a process of finding out. It is defined as the process of finding out dimensions of the product or a component. It is a process of finding out the dimensions of the product or a component or an element by using the technical formulas. That is the design. Okay. Now you have to complete this figure also. Whatever the chart is there in front of you, flow chart, you complete this flow chart. You note this flow chart. That is a identification of need, first point. Second number, a design of problem. Third, synthesis, analysis and optimization, evaluation and presentation. Okay, so these are the different types of things that are in the our design process. Please everyone find out, note it please. Please everyone note this particular chart in front of you. If you have completed, then we'll move for the next point. I will give the 1 or 2 minutes to complete it. Please complete.
Sir, completed.
Yes, good. In front of you, there is a one part that is called as a shaft. What is this shaft? It is like a circular rod having the number of steps you have observed on the particular PPT. So all of you to see here, here is a diameter D1, second is a diameter D2 here, diameter D3, diameter D4. Like there are 4 diameters are involved here. It is called as a stepped, number of steps are there. Normally shaft is one of a rod. You see in the home also, in the room also, your fan is there. To the centrally there is a shaft is placed. To the bottom side the blades are attached. When we make it a fan on, that rod that is internal shaft that rotates and will get the movements, blades of the fan movement will get it. So likewise, this is the shaft. Here four diameters are involved. Normally the shaft is having the only one diameter, the 20 millimeter, 30 millimeter, 40 millimeter diameter shafts. Okay. Again, the shafts we are using in the four-wheelers, in the two-wheelers also. Again, in the fan, everywhere there is a rotation part will come. Obviously, shaft is involved there, directly or indirectly. The shaft is a circular component which is made up of a certain material. That material is cast iron, steel, which are of a different grades. Okay, steel are of a different grades. Okay, when we are using of a different grades, its strength is important. Is Young's modulus is important. These are the material properties which are associated with the particular type of material. Shaft. Okay, so design of shaft, and that is a part of one component. I had taken it for a simple design process. Okay. Then if you are going for the shaft, okay, so there are different types. Machine shaft, it is the integral part of the engine. If you have seen while servicing the any vehicle, you come across with the shaft. You come across with the different types of engines. Okay. If in front of you somebody has opened the engine while you're doing servicing of your car, two-wheeler, you see the how exactly the parts are there. How there is a this different parts work. So in that shaft is obviously one of a component or one of the element. So main function of shaft is to transmit the motion or a power from one part to the another part. Okay. It is called as a transmission shaft. Shaft motor to the compressor. That is a it transmits the motion from motor to the compressor. Okay. So that is a function of shaft. Shaft can be used in the various applications. Basically, these are classified into the three types of shafts. One is a solid shaft. Okay, solid means it is a continuous throughout, just like a rod. The shaft which is available in our fan, that is the solid shaft. Hollow shaft is the shaft which is having the hole inside, like this inside hole in this finger. That is a hollow shaft. You see, so here is also the hollow shaft. You see, centrally there is a hole. That is a hollow shaft. Then steps are provided. These are the number one steps. Second step, three. Yeah. These are the steps. That is called the step shaft. So previous example is of a shaft, hollow shaft plus the step shaft. Both the combination are there in the particular type of shaft. Okay. Now failure criteria are there. Okay. What are those failure criteria? Suppose this is the shaft in front of you. In a working condition, it may get break. How it will get break? When there is a lot of load, when there is a lot of force is on the particular type of shaft, then it will break. To avoid that, we have to use the failure criteria. Okay. So here, the machine element is said to have failed when ceases to perform its intended function. So it's not able to perform properly, means it's failed. Okay. Sometimes there is a deflection in the shaft. Sometimes there is a deflection, is in the micron neglected. It is a 1 micron neglected, 2 micron neglected, but it is a millimeter, 2 millimeter. It is not neglected. So that's why the specific dimensions are very important there. Due to the loading of, due to the running of the shaft, there may be the stress coming on the shaft, and due to that, there may be the failure of the shaft. It is for the shaft, it is for the blades, it is for the any machine component that failure is there. Secondly, excess deformation of the particular element may lead to the unwanted interference between the machine elements, like a jamming of a machine, etc. That is also the failure. So in our home, the bearing is there. When bearing is placed in the particular type of fan, is at the two ends, the bearings are placed. On the shaft's two ends, the bearings are placed. After over 1 year, from your fan, the noise is coming. We may say there may be the failure of the bearing, not a shaft. Due to the continuous rotation of the bearing, there may be the liquid in it. Okay, that will become less. Okay, lubrication, that liquid is called a lubrication. Lubrication become less. Due to that, there is a tearing or pitting failure of that particular bearing will take place. That is also the failure. Although any component in the machine is damaged, it has a failure, then our machine cannot work perfectly. In the fan, the bearing is failed. Although fan runs, but it makes the excessive noise. That is irritating to our ears. That is again a failure of the fan. Engine, sometimes the windings in the fan will get burst, will get damaged. In that situation, the motor in the fan will get failed. Due to that also, fan cannot work. These are the different conditions. These are the different parameters that are related with the machine. Fan is the one machine. I am giving you the simple example for the understanding purpose, to understand very clearly. We can give the example of the car. In the car, so if you are not doing the servicing, the coolant or a liquid in the engine may get less. It creates some damages to our engine. Okay, lubrication is continuously required there. Again, gearbox oil is get less or it becomes black after a lot of use. We have to replace it. Otherwise, it creates the problem to the transmission. It creates the problem to the transmission of motion or a power. Okay, so that's why we are doing the servicing of our car or two-wheeler after every 5,000 kilometers. After every 6 months or 1 year, we are doing the servicing. Okay, so according to the number of kilometers, 5,000, 7,000. Okay. So this is due to the avoid the failure of the material. Again, stress development is there in the material like ductile material. In the ductile materials, it reaches the yield strength, it start the yielding, and there may be the continuous deformation will occur. That is come under the plastic stage. What is that plastic stage? So there will not be any elasticity of the material. You are hanging the rubber, it put under the tension, you release it, it will come to the original position. But it is in the same condition. That stage is called as a plasticity. Okay, so it will happen with the ductile material. Okay, This is small deformation will occur. That is called as a spring back effect in the material. Okay. Secondly, the brittle material. What is this brittle material? Where the more percentage of carbon is there, that come under the brittle material. Very small plastic deformation will occur in this type of material. If there is a more deformation, the material will get fail. Material will get fail or break. Okay. So it reaches to the ultimate tensile strength. What is the ultimate? So I will tell you the simple example. There is a simple graph. Initially, the stress is directly proportional to the strain. That condition, stress equal to E into capital E into small e. That capital E is called as the Young's modulus. That capital E equal to sigma divided by small e. That is stress divided by strain. That is called as a Hooke's law. When it is going certain that Hooke's law at a 45-degree angle, that line is there. After that, again I am increasing the load, is the yield stress. After that, yield tensile stress. Yield stress, okay, permissible, some swim back. Yield stress, again it is going up. So then there is a ultimate tensile strength will come. So at that time there is a failure of the material takes place. The failure is happen everywhere. In the mouse, laptop is suddenly fallen down. There may be the damage to the outer periphery or inside some part. Mobile, when it fall on our floor, there may be the damage. So it cannot bear or sustain excessive load. We are applying the cover to the mobile, like this cover. Why we are applying the cover? To avoid the failure of the particular mobile. Okay. We are putting the heavy covers, so to avoid the failure of the mobile. It is a very simple example in front of us, but practically when we are going for the any machine component, then we have to take all the parameters related to with our design. Okay. Now everyone, I think you got the failure criteria. Now you do one thing, shaft, and this matter only note it, please. So I will give the 2 minutes. Please complete within the 2 minutes this matter. Simple example is there, and complete this one. See here, types of shaft, machine, transmission shaft, and these three types. If you have completed, then we'll move for the another part. Hardly require the as 1 minute. And somebody is interested in drawing the figure, this circle, simple circle, solid shaft like this, and this hollow shaft, please draw the figure also, so that there will be the better understanding about the shaft. Okay. Some of you are taking the screenshot, not required. Draw it. So after 2-3 days, I will provide the PPTs also, if you need it. So whenever you will go in the any industry, or maybe you work in some industries, so you will come across with so many departments are there. Marketing department, sale purchase department, quality control department, design department, sometimes called as a research and development department, R&D. Then production department, production planning department, quality control department, then packaging department, and again come under the lastly the marketing, dispatch with marketing. So this is a cycle. This cycle happens everywhere. In every industry you will visit, this happens. So we are more turning towards the chemical oil refinery plants. So in that one, so we are making the drilling operation to make the oil wells. Okay, drilling operation is very much important. So in the drilling operation, the shaft is involved. Drill bit is there that is going down. That moving part. So that is nothing but the shaft. Having the different, you may call it the tool also, but it is the main function is like a shaft only. Drilling operation only. So these are the things everywhere. Our design aspects, machine design aspects are involved. You can take any example. Now failure criteria, just we will learn the failure criteria. Now. So how to design the machine component or a machine element? I have given the example of the blades of the fan. How the blades of the fans are designed. What are the procedures are involved in the blades of the fan? Initially, specify the function of the element. Specify the functions of the element. The function of the element, blade to give the air to us. That only the rotates. Okay, that is the function of the blade that is rotating. Okay. Number one, that is the function. Number one, you are noted. Number two, determine the forces acting on the element. What are the forces are there on the fan blade? What are the forces are there? There is a self weight of the fan, self weight of the blade, that is a main force. Again, the gravitational force that is acting in the downward direction. That is the second part. Third part will come the suitable materials for the elements. Blade is made up of the steel grade. Steel, okay, stainless steel, number one. 40C8, 45C8, 50C8. These are the different grades of the material. From that, it is made. Next point will come fourth, failure mode of the element. How it fails. The blades of the fan, how it fails. Excessive loading, number one. We are putting the extra load on it. Number two. So what is the extra load there? So I kept the weight of 50 kg on the blades of the fan. Definitely it will damage it. It will change its shape. That also the failure takes place. Okay. Again, bearing cannot work perfectly. It affects on the blade. Blades cannot move perfectly, but motion will not get perfectly. Okay. Determine the geometric dimensions of the element. What are the geometric dimensions of the element? What is the length of the particular fan blade? Suppose 60 or 600 millimeter, you can say 600 millimeter. Some of them are 600 millimeter. Some of them are the 300 millimeter. Whatever these dimensions are there, these are the standard dimensions. You go such and such type of blades you needed for the fan, you will get the same dimensions. You see the charger of the mobile for a one company charger, the charger is of the same type, but we cannot put our charger of the Samsung to the Apple phone. So there are some charger slots are there. These are also the 4 or 5 types of slots. These are very standard. Okay, we have to take that type of charger only. Okay, so I'll have to see why I'm telling you this example. geometric dimensions. All of you to see this also. This charger, okay, whatever the charging point is there, it is a somewhat bigger compared to this one. See the dimensions. Again, you see the color also. It is a black and it is a white. See again here they have mentioned the charging from charging some symbol they have mentioned, but here symbol is not mentioned from where to put it. Here some design is given like this. Here design is not given. This simply step is there. Okay. These are the things. Whatever these cables are there, white cable and this one, it has a certain diameter. Okay, but these are not sharp. Okay, so these are having a certain diameter. That is also the looking somewhat same, but it is a somewhat bigger compared to this one on the dimensions. Okay, so this is the design we have to learn. We have to learn such type of designs. Suppose tomorrow if you want to manufacture such type of cables, chargers, then so that is a process here. You have to design, suppose design, how to design it then? We have to make the model in the CAD. Okay, so how to create that model in the CAD? We have to analyze what is the length of it. So what is here dimension, this side, okay, 2 slots are there. These are the things that we have to learn it, that we have to understand from this particular sessions of our CAD CAM machine design and CAD CAM CE. That is the aspects. These are the new things that we are learning. Maybe you know the mobile, you know the charger. You are having a lot of things in your mind, but you have to see that things in the engineering point of view, in the intern point of view. As an engineer, how will look, how will see the particular component. These are the various parameters or aspects or ideas are there. Modify the dimensions of the assembly and manufacture. Check the design at the critical cross sections. So yes, obviously I am manufacturing it. I have to check the design, where it can be modified, how it can, but this point is a standard. This point is a standard for both the cables. Okay. So all of you to observe, this is the standard. Okay. This point, see it. There is not a change in the millimeter or in the micron. See this point, this projected point here. There is no single change in this dimension. That is a design. If I will change this by the 1 millimeter, it cannot work. It is rejected in the company. In the micron, they are checking this dimension. Every company. So these are the things. These are the engineering point of view. You are looking this particular charging points. You may call a USB port. Okay. So these are the things that we have to specify. We have to give the new innovations. We have to give the new ideas to the customer, new ideas to the company, new ideas to our people, to our society, to our nation, to our world. That is our aim. That come under the ideation and the innovation in you. Give the new technology, give the new software to the people. Initially, you learn, you grasp the things, then you can modify, think. Everyone is having the very good mind. You apply the knowledge. You gain the knowledge and apply it. Through the intern expert, you are having the very good platform. You associate with us and we'll explore you in all the dimensions. In the engineering aspects, in the software aspects, in the mechanical, civil, computer, IT, petrochemical, chemical. So again, the MBA, MCA, pharmacy, again, you are related with the architect. So any platform, people are there, students are there. We are here to guide you. We are here to support you. Here, we are here to initiate you to become the entrepreneur, number 1. To get a job, number 2. Assist you for the placement, assist you for your future career. We are here. Only giving the industrial knowledge is not a sufficient. Apart from we are giving the some civil writing. So this type of aspects are there. Commercial aspects are there. Industrial aspects are there. Financial aspects are there. On the every part, we are with you. We are helping you. Okay. Now, I'll have to draw this figure also because this is very important. It will come everywhere also. Please complete it. Hardly require 2 minutes, please. Please, all of you to complete this part. If so, we'll give the 1 minute more. Please complete it. So meanwhile, anybody has any doubt or question, ask me, no problem. Please ask me the question also. Whatever the portion we covered, please ask me the question also. Then again, I will move for the next part. Please. Everyone have to hear the session. Take the simple, note the simple points. And lastly, while the session will be over, so I will ask the questions to you all, or you summarize the session, what you learned today from a particular machine design and CAD/CAM CE topic. Please, I will ask the question also.
Hello, sir.
Yeah, please.
Good evening, sir.
Good evening. Yeah.
Sir, I have a question.
Yes.
Sir, which designing software is the best among all, like CATIA, CAD, and SolidWorks? So, which one is best?
So what happened? So many industries are using for the modeling CATIA software. Okay. Some people are very much interested in the SolidWorks. SolidWorks also very useful for the modeling, and CATIA also. Okay. And some of the companies are using the ProE also, ProE software. Okay. So these are the basic modeling softwares the companies are using. That's point number one. Number two, for the analysis. The analysis is placed in the ANSYS. Some part of analysis is placed in the SolidWorks also. That is the second. Okay. Two parts are get clear. Third part will come the meshing. The meshing of the component is also the very important. The meshing is of various types: square, triangular, rectangular, hexagonal, tetragonal. So for that also the different softwares are there, special purpose softwares. Hexamesh. Okay. Again, this is what all this work. Next part will come the household applications. The pressure cooker. The glass, water glass like this glass. Okay. So whatever these different types of components are there, for their manufacturing, we are not using the simple tools like ANSYS or CATIA or SolidWorks. We are going for some PAMStorm. Again, the PAMStorm software that gives us the better results compared to this one. So these are some types of software that are used in the industries. Okay. So PAMStorm is available. That will give us the information regarding the flowability of the material. First step drawn, second drawn, third. In the 3 steps, some components are manufactured. So in that situations, the other softwares are there, PAMStorms are there. Okay. So these are the various softwares, or these are 3-4 major softwares are there. that are normally used. Some of you are from the civil background, if you are there from civil background. For structural analysis, from the beams and the columns which are made up of the steel, we are using the StatPro software, StatPro. So that is also the one of a software that is for the structural civil analysis. You observe in the different types of plants, you take an example of oil refinery plants, the big structures are involved. How that big structures are manufactured, are designed, done its CAD modeling and analysis, again how they are manufactured. All the questions will come in our mind. So at that time, those StatPro, our structural analysis softwares are very much essentials. Again, next part will come the CFD, flow type of problems are there. Oil flow is there, chemical refineries, oil flow, petrol flow, diesel flow, water flow. How it can be regulated? I manufactured the pipe, but how to measure the flow in it? I cannot use all the time petrol, diesel, I cannot waste it. So through the software, I will initially initiate that concept. The CFD is there, that some part is available in the ANSYS. There are again the specialized CFD softwares are there, computational fluid dynamics softwares are there. Again, our Rameshwar sir is there. He's also specialized in the software. He has also developed a few softwares related with the CFD. So all these are the various scope for the CAD/CAM C and CFD softwares in all industries. Plants, manufacturing, production, automotive, oil refineries, gas sector. So manufacturing of the laptop PCs. So everywhere, heavy duty machines, watch manufacturing, so many, a number of products are there. There is a need of such type of softwares are there. Okay. I hope you got the answer for your question. Okay.
Yes, sir. Sir, I have to ask something else.
Yes, please.
Sir, which type of software is used for designing machine elements in oil and gas industry?
In which industry?
Oil and gas industry.
So what happened in the oil and gas industry? Suppose I am getting the project on the pipe design number 1.
Yeah.
Pressure vessel design number 2. So I.
Sir, voice is interrupted.
Hello. Getting my? I am audible. Am I audible?
Yes, sir.
Yeah. So in the oil refinery plant, what happened design of pipe number 1, design of pressure vessel number 2. Okay. If you have taken these 2 examples so initially we have to model it in CATIA. Okay. The again solid work also equally important or useful to model there. Okay. Pipe. If I model, I've done a CAD model there, I have to import in the ANSYS. Before importing also, I have to do the analysis of it. That's why the meshing is very needed on the various components. That meshing I will do in the another software. Examination. So that meshing software I will use again after meshing all this thing. I will import in the particular software. There is ANSYS, and I will do the analysis there. For that also need a couple of days to complete all the thing problem, define the problem, input, and after that I will check the various point related to the pipe design number 1, pressure, temperature inside, that is the number 1. Stress analysis I will check it there. Okay. So with everything with material I will test it. with everything it is comfortable within the limit zone. If that model is working around 80% correct compared to the practical 100%, that is a fine model. Okay, we cannot give the guarantee of around 100% through the software. We can proceed up to 80%, 90%. Okay. That's the one part. We can do the simulation of that particular model, how it can be there, the stress strain analysis, that part in the pipe design. That is for the part number one. Part number two, pressure vessel design. It's a very big component in the pressure vessel design. We can divide that project into 4 different parts, 5 different parts. We can take one component for the modeling, then doing the analysis, everything results are comparing. Then we are joining all the 4 or 5 components. Then we will do the total analysis of the particular pressure vessel, because it has the very large dimensions. It requires the couple of months to complete the work of it. It is not somebody has made a model in the couple of hours and are testing. It is not happen. Okay. It requires a couple of months to complete the process. Okay, then will definitely our model works perfectly by pressure, temperature, by the adding the forces, loads, conditions, material conditions. Again, the failure criteria is where to put it there. Constraints are there. Again, holding is there. Everything where to put it there. Okay. So all these are the various things that are happening in our CAD/CAM CA industries. Okay. So very interesting models comes, and we have to apply our brain. We have to apply our experience. We have to apply our logic to complete the problem. Okay. And failure is there sometimes. Okay. It is not a once model completed and everything is happen and getting 100% result. It is not happen. We have to do the trial in the model also. We have to check the parameters, how these are validating, how these are coming up and down, and how these are suitable there. We have to check in all aspects. Okay. So these are the things. Okay.
Hello.
Next.
Sir, good evening, sir. It's Pallavi here. So as you're talking about pressure vessel analysis, doing in ANSYS. Sir, I did the same, but I have not. In fact, it is very hard to develop a 3D model in ANSYS. What you told, same thing happened, but I did in Workbench.
ANSYS Workbench, na?
Yes, sir. Because it was not all possible for me. It took me for 6 months, all completing all of the parameters, and later on my laptop was hang because it was so messed.
So it is correct. You are correct. I am telling that. So modeling, we have to use the another software. It is not like everything we can do in the ANSYS. It takes a couple of months. Just I am telling them. And
But
we
sir,
need higher end machines.
Yeah.
In the laptop also it is not possible. Maybe you are having a good graphics card.
No,
So
not.
we need the higher end machines. So just I have given one simple example, but so it is not possible there in the ANSYS 3D model is not possible.
Exactly.
You are
So
using
that's
ANSYS.
Question is, like, though we do the things in ANSYS, but ANSYS does not support for everything. There are lots of problems are coming over there while we are using or going ANSYS. And for pressure vessel, when it comes, it is definitely a big problem. I think so. I've faced it.
Yeah.
So, sir, can you I did this, but I never I didn't identify among Workbench and particular ANSYS. So what is the basic difference among them? Can you please tell me? I didn't identify that.
So ANSYS Workbench and main ANSYS, na?
Main ANSYS, yes.
So maybe ANSYS Workbench is an advanced tool that is developed by the ANSYS. Okay. So what happened now? Basically, I give the guidelines where it is a failure occurs or how to perform the problem. But I basically, my peoples are there to work on the ANSYS. Frankly speaking, okay. I handle the projects where technical difficulties are coming. Okay. So sometimes pressure is high, temperature is high. Okay. Sometimes they are facing some meshing problem. So at that time, I support them. Okay. So for you can do like this, like that. Okay, that I give the guideline. But I'm not sitting in front of the laptop or computer to solve the problem of the ANSYS or Workbench.
Okay.
My people are there to work. My team is there. Okay. So I only the handle whole the team. I am not basically take a model to work on it. So I am not perfect in that particular answers to do this that, but I give the technical support. So some problems are there in the particular model. What they have to do. So that point I will highlight. Okay. So near group is there with me, and we handle every problem. Okay. So I basically deal with some big project, how to take, how to handle the projects. So team leader is there. I will assist him for the team leader. Some problems are coming. The technical experts are with me, so they will handle the every problem. So this is frankly speaking what exactly I do.
Okay. Thank
So
you, sir.
technicality, I will check only where it exactly that fails. Okay. Software part is dealt by my peoples. Okay. So everyone has completed this part, and we'll move for that problem also. So I will give that details of the problem also. Okay. Madam, in which company you work?
Sir, actually, I'm not working anywhere right now. I was assistant professor in a government engineering college, Karad. Basically,
Okay.
it's my MTech project.
Okay, okay.
So I had a tremendous headache while doing all the stuff. I
So it
told
is
6 months, but it was sir, whatever parameters you told, I have experienced everything from right from modeling
modeling. Yes,
to
yes, yes.
making the gussets to making the everything.
Yeah, yeah, yeah.
I first prepared whole model, then meshing. Then it was like my laptop was all stopped working. I did half, I did 1/4, I did analysis. What all the stuff I did to get the results.
Okay, okay. So what happened? So I am basically support for all the technical parts. Okay. So I am not compared anything with the workbench and the ANSYS, but to guide them, to give the proper inputs. That is work that I am doing here, technical support. And
So what
obviously
very
the
nice.
people. And what happened with me? Some foreign peoples are there. They work with some foreign companies. They are working with me, and such type of problems are arises. I support them. So normally, some projects are there from the Iran and Iraq that is related with the oil refinery plants, pressure vessel design. So they are checking some standards. Okay, so highest standards are there. Okay, they are checking with our certain standards, and finally we complete the deals. Okay, that is a professional deals. We complete it, and really the good manpower is available with me, and the support to our total company.
Yes.
And hence onwards, if you face such type of any problem,
Yes.
so I will assist with my colleague. He will definitely give the very perfect solution to your problem. Okay.
Yes, sir. Yeah.
So, yeah. And what happened? They prepare the report, and the report some problems are arises with the clients. Will definitely check. So these are the problem arises with the particular report. Maybe the pressure, temperature points are there. The meshing difficulties are there. Okay. At this point, the temperature, suppose the 1000 degrees centigrade, they need a more, they need a less, like that. Whatever the things are coming there. So I'm guiding them, and they are doing a perfect model there. Okay. So maybe if you are having certain such type of some industrial projects now also, so we'll complete that work also. There is no issue about that.
Yes, sir.
So what happened when you are using our laptop now? Graphics card is less. Maybe you are using the i5 laptop or maybe the i3. I don't know. And definitely it cannot support.
No, sir, not at all.
It cannot support our particular problem, and it took a lot of time. Okay. So what happens sometimes if we are doing the simulation for a certain simple component, so we put it in a night for 6 p.m. and we have to wait for around 12 hours to get the analysis of it.
Exactly.
12 hours, sometimes 18 hours. Till also we are not getting the full analysis of it, full solution of it. So these are some technical difficulties are coming. while we are handling some industrial projects or live
Yeah.
projects. Okay.
So the same I have suffered with. I kept for 12 hours, 13 hours
Yeah,
to
yeah, right.
whatever, but I go. So actually it deals with the meshing. When we
Yeah,
do very fine meshing, that it will take a more time, because
yes,
every element, every node, it has to calculate
yes,
how
yes.
fine mesh we do.
Mhm.
If we do coarse meshing, sir, it will give a rough result and very fast result.
Yes, yes.
With a very fine meshing, it will take a lot of time.
Time
Sometimes
also.
more than 12 to 13, 14, 15
Yes,
hours also.
yes, yes, yes.
So,
Yes, it is good. So, are you handling any industrial project now?
so no, sir. Right now, I don't have any project, but I love to if any project comes to me like that.
And you are working in the same college, government
No,
college? No?
no, sir. Right now, I'm not doing anything due to I moved to Hyderabad due to some reason. So I'm now at home only.
Now, if you want to work on the some ANSYS part, if you are very much interested, so then I will in a couple of days I will initiate some projects, and if you are interested, by sitting at your home only, I will initiate some project for you also.
Okay, sir. Yeah.
And if you are free, comfortable, then I will initiate. Okay.
Yes, sir.
So may I know your name, please?
So my name is Pallavi Pudke.
Okay, Pallavi. Okay, no problem. So some clients are there from the Hyderabad also to my company, and I did a lot of work there. Uh, and some clients are from the another part of world like Iran, Iraq, Kuwait, again from the Sweden also. So again from the Mercedes-Benz also. So I worked with the Mercedes-Benz group in a couple of years back. So we have some models from the bench also for doing the analysis. But I cannot explore all those things. Okay, these are some company secrets. Okay. So we are having some multinational company with us, and we are handling the good projects.
Yes.
So if you are interested, so definitely keep in touch. You also, and any person from our group is interested in the CAD CAM CA work. Again, 3D printing, you are most welcome here. So we are having a good project with us. That's number one. Again, if you are having any complicated project with you, with your company, that also you can give it to us for solving. Okay, you can give that project to us also. Okay, that is also the two-way process. If you are working the company and limitations are there for the company, the manpower is not there, or maybe the unable to solve the problem, then you can divert to me. Number one. And if you want to work with us, that is also open platform you. Okay. So these are the things from my side to you all. Okay. Thank you for asking the questions. Now we'll move further. So I hope everyone are completed. Those who are working and those you know everything. So it seems to be easy. But those who are from the other background, so please note it also. These are basic things, but needed. Okay. If I will teach here, if I will give some information by audio, video, whatever the things are going on, so we'll get it for 2 days, 3 days. But for a long term, so it is better to note some points, and it is helpful for our projects also. I hope everyone have completed it. Now we'll move further. I will give the simple example of the key. I will give. Okay. Main function of key is to join the two parts. Okay, it is act as a lock in between the shaft and the hub. Okay, so I'm giving the simple example to get the insight about the machine design. What happen if I will go directly for the CAD and can see? So these are the things happening. Then we forget regarding the fundamentals, what exactly happened previously. That's why I'm taking this simple examples and the problems for you all. Please note that was also. Okay. So all I have to see here in the machine design. So we are going for the design of component. So at that time, I'll have to see this is the shaft. I given the example of the shaft. Now this is the hub, outer periphery. In between the shaft and hub, the key is placed. This key is the square key. This key is useful to transmit the motion or a torque from shaft to the hub. That's the one point. Secondly, it acts as a lock between the shaft and the hub. So these are the two major functions of this key. I'll have to see this key is here. Small part. Okay, that is the key. Here, the forces are acting on this key. When the forces are acting here, I'll have to see this is in the right direction, toward the right direction, and the second force is towards the left direction. Two equal opposite forces are acting on the key. When these forces are acting on the key, there is a shearing phenomenon will take place. There is a involvement of stresses. There is a development of stress is there. Whenever there is a development of stress, there is a strain developed. In this one, all I have to see the inside part is having the diameter capital D. Okay, outside hub, it is provided with a certain diameter. Again, the in between the shaft and the hub, there is a slot like this groove or slot is there like this. In that slot, we are provided with the key. That slot is called as a housing of the key. In that house only we have to keep the key. When it works, when it functions, so at that time it is perfectly placed. After the lot of functioning, so there will be when it functions at that time, so many forces, loads are acting on this key. So it may be the square key or flat key. So when the forces are acting, there is a shearing phenomenon occurs. Due to the shearing, there is a shear stresses are coming. That is denoted by the tau. Normally, when it transmits the torque, everyone know the torque equal to the force into the perpendicular distance. That torque is defined as the force into the perpendicular distance. Therefore, to find out the value of this force EF, therefore that EF can be written 2T, 2 into torque T divided by capital D. This is a problem in front of us. Okay, we have to model it, we have to put it there. So it is a simple problem, maybe complete within the one day. Whatever the analysis of it, everything we can complete within the one day, maybe the 8 hours, 4 hours. The experts are there, within the 2-3 hours they complete. Okay. So when you are doing the analysis of it, what exactly happened there? So what is the material of the key? Key material. Shaft material, hub material. This matters a lot. Everywhere in the manufacturing, the material is very important. Everything depends on the material. Material cost is less, product cost becomes less. Material cost is more, product cost becomes high. At a cheaper rate, we have to purchase the steel, aluminum, cast iron, whatever the material required for our company. According to our application, according to our need, we have to purchase, put it in the stock, and go for manufacturing. Go for design first, then manufacturing. While we are doing it, we have to see all the technical aspects, how exactly the things are happening. Everyone know what is a design, what is a design procedure, how to design everyone. We have to apply all these rules to here for this model. When we are doing this one, so I'll have to see here how this part is from here we are taken the cross section. Okay. So here I'll have to see in the figure number A, and there is a square key. In the square key, height and width are equal. What is the square key? Square key is the key where height and width are equal. Okay, you forget about the length here now. Secondly, the flat key where see the height is h, width is b. Here width b is greater than the height h in the flat key. So this is the basic difference I am telling. Okay, this is the basic information I am telling. So now here, while discussing the pressure vessel problem, okay, that is it seems to be a very big problem for a couple of months or years. But when we are taking the small components are there, which are involved in the pressure vessel design, which are involved in the pipe design, which are involved in the lathe machine design, which are involved in the press machine design, okay, bending machine design. So initially we should know the simple product, simple component design, then we can go for the any complicated part, any complicated problem, any complicated type of product. Okay, so this you see here B equal to H and B is a greater than H. In this case, after a couple of years, when you are working in the industry, you come to know what is the width, what is the height, what is the torque. So your mind works in that direction, and you will get the different types of dimensions by your imagination only. The dimension would be the 30 millimeter, but you have to do the calculation. The dimension would be the in between the 15 to 20 millimeter. So you will understand by your own after a couple of years. But till also we have to work on the paper. Really, that problem is coming that answer or not. So that is the main work of the design engineer. We cannot give the all the imagination answers there. Okay, we have to give the some perfect answers. Okay. Now, so this is the one problem in front of us. We can solve this problem. Okay. So what exactly happened in the design? What we have to do in the design? Okay. Yet they mentioned the industrial practice is to use the square key with the sides equal to 1/4 of the shaft diameter and length at least 1 times of the shaft diameter. Everything in this problem is defined in terms of the diameter d of the shaft. Means see, the design of shaft is very essential everywhere. Yeah, B equal to H equal to D by 4 for the square key. B equal to H equal to D by 4. D by 4 is not a national standard, international standard. It is a thumb rule that is coming here for a design of key. So we had, it is only the thumb rule that is coming here. After a lot of experimentation, they have come to the notice that B equal to H equal to D by 4. Then length of key L equal to the 1.5 times the D. So you know the width B, height H, length of key L, small l, D is the diameter shaft. Okay. So all above information is for the square key, whereas for the flat key, width B equal to D by 4, height H equal to 2/3 of B. In terms of D, if you want to calculate, put the value of B here, D by 4. Therefore, we'll get H equal to D by 6. That is the dimension of the H, D by 6. Length L equal to 1.5 times of D. So if I given the diameter of shaft is 30 millimeter, you are able to get B value, H value, L value, then you can able to design the key. Again, I am giving the force 100 kilonewton is acting there, then you are able to do the analysis. Somebody is giving some meshing information like that. So many inputs if you are getting, you are refining your problems, you are approaching to the approximate 100% solution. You may call it the approximate solution, not a correct one, but approximate solution. You are closer toward the 90%, 95%, 98%. So these are the dimensions to find out while you are doing the design procedures. Okay. Here in this one, all have to observe the square key is having the load P here like this. This is the surface A, surface B. P dash is the load vertically upward direction and vertically downward direction. All I have to see here A point, B point, C point, D point. The shaft is there. The shaft is rotating with the torque mt. We may call as a torque T or mt. These are the different types of notations for the torque. Some books, some industries are using maybe the torque T, correct? Somebody are using a mt, that is also the correct. The exact location of the force P on the surface of AC, you see the surface of AC is unknown. Try to understand the problem. The location of the force P on the surface is AB is unknown. Same thing, the force P is unknown for surface DB. This point, how to locate it? You cannot see the load acting on the body is by the open eyes. Can you see it by the open eyes? Force is acting? No. So in the software, sometimes you are putting a certain load, you will get some deformation there, maybe some zones you are getting, green zone, red zone, or different types of zones we are getting. That is a load is acting there. But at a certain point, if you want to point out the load, we need the meshing part. We need the different types of nodes to analyze to get the point-wise analysis of the force P, stress, and strains. Again, you see the upper part, P dash is acting like here, like here. This is the complete problem which with us. Then we have to analyze this problem, how it is working, how it works, how it can be a practical, how it can be a feasible for us to solve. In order to simplify the analysis, it is assumed that force P is tangential to the shaft diameter. Therefore, P equal to mt divided by d by 2. Therefore, 2mt divided by d. So all of you to see force P equal to torque mt divided by the d by 2 is the radius. 2 is the radius. Therefore, P equal to 2mt. Therefore, P equal to 2mt. That is equation number A. Mt is the torque transmitted, that is in the Newton millimeter. D is the diameter of shaft, that is in the millimeter. F is the force on the key, that is in the Newton. So all of you to see the problem seems to be very simple. But when we are going the technical details, we have come to know the depth of the problem, how depthly we are going, how we are going the point wise, like a force, torque, load, and then stress, strain, then value of P, surface, every factor is coming here. Now in this one, I'll have to see the figure number A. So it is a complete block like this. Then the force is acting like this in opposite direction. There may be the shearing action. Shearing action. That is called as a shear failure of the key. That is called as the shear failure of the material. Number 2, all of you to see the force, how it is acting on the surface, and this one. That come under the crushing. The crushing force is there. Due to that, one crushing occurs, and the crushing failure takes place, and that is a sigma CR. That is a crushing stress. Here in this one, the shear stress on the plane AB like this. That is a tau equal to, that is stress equal to the, stress is the internal resistance induced in the body. Internal resistance induced in the material, that is the value of sigma. Sigma or tau, all these are the stresses. Tau is the shear stresses. Therefore, load P, tau, how to define tau? Here, load P divided by area under the AB. AB, below AB, the area. What is the area? B into L. P into P divided B into L. So that is we are getting the value of tau, where B is the width of the key, L is the length of the key. From equation A and B. What is the A equation? This is A. From equation A and this equation B, what we are getting tau, you can put the value of P in the equation number B. So what we are getting here tau, that is a 2mt divided by dBl. That is a shear stress. Here, failure due to the compressive stress will be on the surfaces AC and dB. AC, where is the AC? AC and dB. They are telling here, compressive type of stresses are there. Okay. Due to the compression, compressive stresses are involved. You may call it crushing stresses are involved there. Therefore, crushing area between the shaft and the key. Okay. So therefore, AC, this AC VD equal to H by 2, height H by 2. H is the height of key. Therefore, here sigma C, force divided by the area under the AC. Therefore, P equal to H by 2 into L. H by 2, half of the height into the L. This will go up here, 2P divided by HL. Here, value of P in the equation number C, put it. So from the equation A and B, what will get the value of sigma C? That will get 4mt divided by D into H into L, 4DHL. So this is the complete design. You may call it as a derivation. It is for the understanding purpose what exactly happened in the design. Okay, so that's why we are getting the value of sigma C here, 40 divided by DHL. Okay. So above is for the design of key. Then we have to go for the stress equations for the square key, that is H equal to B. Whatever the equations are there previously were learned, tau equal to 2mt divided by dBl, and sigma C will become the 4mt divided by dBl. So what the theoretical information we are getting it here, sigma C, compressive stress, sigma C equal to the twice of shear stress tau. So this is the some empirical relationship you are getting here. This is a one type of design. So everywhere design, if you are getting design of car, design of model, design of laptop, design of is, so design of key is here in front of you. So this is a design. We are going the technicality of the design. Okay. Everyone had to note this figure, draw this figure, please. Design of machine element, that is the key. Draw this only, this figure only. This figure only, complete it. Please complete it. Hardly require 2 minutes. Please complete it. Please, all of you to complete it. Please, everyone complete it, please. So I hope all of you have completed the figure. Please complete it. I hope you are completed. We'll move further.
Sir, complete.
Yeah. We'll move further, no problem. So this design need not have to write anything. Okay. It's what exactly happened in the design. You do one thing only, the simple thing here. Design of key, you can do one thing here. Equation number A, B, and this last equation. Okay. These three equation, note it. Okay. This is important. Okay. Design of key, at least you should know what exactly the tau, sigma C, and sigma C twice of 2 into tau. Complete shear stress tau, sigma C compressive stress from A and B, sigma C is twice of tau. Okay. If you are completed, then we'll move further. Please note it, please. So the students which are having the another background like computer science and MCA, chemical, so it seems to be somewhat difficult for them. But so we have to learn. Those who work in the industry, in the mechanical industries or in a design department, it is very simple for those students. Okay, but as a part of this internship, so we have to cover all the such of simple design to the industrial designs. Okay. And I will provide you the one assignment on it on this design of key. So complete that assignment. So here is not only here to give some knowledge, some the industries, what exactly happens department wise. So many students I saw taken the orals of the industrial training students. They are unable to explain anything. They have went in the industry for the 2 months, 3 months, and same related to the particular industry. I'm asking the simple questions. They are unable to give. Okay. So that's why the students who are really physically doing the training, they are unable to give the answer. That is feels somewhat uneasy. So many students from our intern experts, they got the good job. We completed the training in the month of July. After the 10 days only, they got a job. They replied. So we got the very good industrial insight from our intern expert, and really these are very much benefited in our interview techniques, in the interviews. Okay, we have improved a lot of things, technical things, and what exactly happened in the industries. All the inputs are given by the experts from our intern expert private limited, and really the students got a lot of benefit through this online internship program. So you see on the website also, some of you are given the comments on the WhatsApp also to send. And so many students are got the opportunity offer letters also, but they are not completed there. It's a B, they are waiting for it. And from you also, some of you are completed your B or you are working in the industry. And if you want to go for some higher level, so you are welcome here. We'll take your CV also. We'll study it again. We'll motivate you, and definitely that is helpful for you all. Okay. I hope everyone are completed now here. Now we'll go further. So now this is the one of numerical. What happened now? We cannot do the blindly design. We should have the piece of paper. We should have the proper material. We should have the proper properties of the material. Then only we have to go for the design. Okay, this is the one example in front of you. Such type of examples are varied according to the application, according to need, according to the industry. Okay. So we'll take this example. So it is required to design a square key for fixing a gear or a shaft of 25 millimeter diameter. The shaft is transmitting 15 kilowatt of power at 720 RPM to the gear. The key is made up of the material 50C4, that is a grade material, where is SYT, yield tensile strength, is given 460 Newton per mm square. In this one, factor of safety is given 3 for the key material. The yield strength in the compression can be assumed to be equal to the yield strength in the tension. Determine the dimensions of the key. So what they are telling here, to find out the dimensions of the key. What are the dimensions of the key? B and W, L. These are the dimensions of the key. How to find out? Previously, we have learned the derivation, you may call derivation or design of key. Now we are solving the problem on the design of key. For a key material, SYC equal to the SYT. That is the given in the problem. SYC is the yield compressive strength equal to SYT is the yield tensile strength equal to 460 Newton per mm square. So just now, one madam has asked the question regarding the some software. So in the software, running is very important. To run the software, no doubt is good, perfect is required. The technical aspects are really very important. To run the software is one aspect that is also equally important. But how to give the inputs, technical inputs, that is more important. How to give the constraint to the problem, how to give the proper direction to the problem is very important. That directions I am giving. So where to increase the strength, where to use the material, how to use the material, what type of material we have to use, that is the concept we are giving. Give a man a fish, he can eat for one day. Teach a man to fishing, he can eat for a lifelong. So here we are giving the inputs for a lifelong. You are learning here for a 36 hours or 15 days, or maybe in the part is for 1 month, but you will remember for lifelong. It is not the only thing we are teaching here and leaving you. We are we are taking a certain amount of fees, so and we are teaching you. It is not like that. We are here to support you a lifelong, to your career path. Although so many professors, so many your mentors in the colleges, maybe mentors in your industry or some industry owner, they are given a guideline to you. Yes, obviously they are given a guideline to you. But apart from that, how you can stand by your own in any condition, in any situation, that is our aim here. Okay, so here after completion of this 15 days, 1 month, it's not like that our relation over. It will be the couple of years. So when you go here and there, you remember all this knowledge. These are the inputs given by the expert people, Dr. Bhagwanji, Dr. Rameshwar, Dr. Sudhir Patil, Dr. Hingole, Rahul Hingole. So these are the inputs for your life, Mr. Rajesh Kumar. Okay, these are the inputs. Again, in the future, while you are in the industry, some problems are arising, some issues are arising. So you contact us. We are here for your support, all technically, commercially, a marketing point of view, in a placement point of view. Okay, so we are having all the platforms open for you. Okay, in this problem, SYC equal to SYT equal to 460 Newton per mm square. Sigma C is a formula here, that is a force divided by area, that is a force divided by area. So in this one, right here, SYC divided by the EFS, that is a factor of safety, that is a 460 divided by 3. So in this one, initially we are finding out the values of sigma C and tau. These values of sigma C and the tau, these are very helpful to check our design is safe or not, to check our design is in the safe zone or not, also to avoid the failure. These are the basic parts which are essential to learn here. According to the maximum shear stress theory of the failure, S of Sy equal to 0.5 SYT. S of Sy is the yield shear yield strength is equal to half of yield tensile strength. Therefore, 460 divided by 2 or 460 multiplied by 0.5, that coming 230 Newton per mm square. Therefore, tau equal to S of Sy divided by the factor of safety here, 76.67 Newton per mm square we are getting. So if you want to do the calculation, do it, no problem. But these are the values we are coming. Here we know it from the design. B equal to H equal to D by 4. What is the diameter is given here in the column? 25 millimeter dia. C, 25 millimeter dia. 6.25. you can make it as a 6 millimeter. You can make it as a 6 millimeter. Okay. And here L equal to, we know the formula from the torque EMT. So L equal to 2 EMT divided by tau dB. Tau, we have found it out here, 76. P is given in the problem, 25. 6 is calculated here. And 2 torque we have calculated EMT. Okay. 198 and 943. So likewise, we are getting the length L, that is a 34.60. Again, we are having another equation L equal to 4L sigma C DH. From this particular equation, we are getting the 34.60. Okay. From equation A and B, length seems to be equal. Therefore, design of key, therefore finding the dimensions of the key, we are making this L as a round figure 35 millimeter. Therefore, dimension of the key B into H into L. B is 6. 6. This is the design of key. B into H into L. 6 into 6 into 35. Once the dimension is with you, you draw manually, you draw in AutoCAD, you draw in any software, this key. Go for analysis, apply the rules. Okay. So this is the design of key. Practically, you can find out the initially the dimensions of the product, dimensions of the component. This is the dimensions we have got it through this problem. In the industry, nobody will give you the problem statement. You have to formulate the problem, you have to collect the inputs, and you have to solve it. The experts are there, they will give the guideline. Now this is the correct. You have to modify this. You have to work according to the customer requirement, according to your the experts in the industry requirement. After a couple of years, you will become the expert there. After 2 years, 3 years, 4 years, then you can give the guideline to the other. You will become the team lead. You will become the manager, general manager, or in a technical parts. Okay, team lead. So like that, then you can give the instruction to the others. Okay. Maybe you are their team lead or manager. I don't know. So you can give the inputs to the people. Okay. So like that, in the today's we will learn what is a design, types of design, then design procedure, we have solved the one derivation, the numerical, everyone. Okay. So thank you all for hearing patiently. And now the session is open for the question and answer. Please ask me the question. Yeah, Hitesh has asked the software is required greatly in the design department among the CAD, CATIA, ANSYS. I think I answered it. Mostly we are using the CATIA and SolidWorks for the modeling purpose. Analysis, ANSYS we are using. Okay. Can you see the comment box? I have asked the question, my question. Okay. Yes, sir. Okay. So anything more from it? Any question or some of you have to summarize?
Hello, sir. Hello.
Ask. Yeah. Ask. Yeah, I'm hearing.
Sir, please tell us about the sources so that we can learn these softwares. Because as a mechanical engineer, I think there is a really very need to learn these.
I will give some links of the softwares. These are available with our previous platform. So I will provide you I will send the link to you. Okay. In the WhatsApp also, the modules are there 1, 2, 3, 4. Lecture wise, you can learn the software. Okay. I will provide the link to you. Okay. Maybe today I will check and tomorrow maximum I will send you all.
Okay, sir. Thank you, sir.
Yeah. May I know your name, please?
Sir, Prashant Kumar.
Yeah, Prashant Kumar. Yes, definitely I will. Abhinav Lal is there. Abhinav Lal. Can you summarize what you have learned today? Abhinav Lal, can you summarize?
Sir, can I explain?
Okay.
What we have learned?
Then, George, can you summarize what you have learned? George? George, Haris, Ghodke. Can you summarize Ghodke?
Hello, sir. This is Rishi Balan.
Yeah. Please summarize. Yeah.
Okay.
Yeah. If you have to ask the question, please ask also. There's no
No,
issue. If you want to ask the question, ask the question. Then I will you summarize.
no,
No problem.
no, sir. I'm not having any doubts.
Okay.
Since you asked to give some
Yeah.
summarizing,
Summarize. Please
so
summarize.
I'm
Yeah.
taking over now. So today we have seen the basic. First of all, actually, what is design, and you
Yeah.
have given a good definition for design. And then we have seen various types of design based on the industrial needs and based on actual formulae and which are giving solutions to the existing problems and using mathematical formulae, all these kinds like rational, empirical, and industrial design types, and how we have to design a material, whatever it be, from a bolt nut to an aeroplane, whatever it is, forms of a basic steps in identification of the need. So what actually it is actually is needed. So what
Yeah.
sort of problem is there? We have to identify the problems, and then we have to define, and then we have to go for options that will give solutions to those problems. And then synthesis is organizing of all these problems and solutions into a single unit, and then we have to analyze. So whether this solution will apply for this problem or not, and we have to optimize it accordingly for the upcoming process needs as per the vendor or the customer. And then after all designing and finding a solution, we have to evaluate whether it is physically and mechanically and thermally feasible or not, and how far it is reliable and durable. All these types of test procedures we have to do for those material what we have designed. And then we have to go for a presentation, and we will go for the commercial production of that particular product.
Yeah.
And then we have get into a typical example of design material, that is first thing we have seen a shaft, a mechanical machine shaft. And then what are the types of shafts? There are mostly solid and hollow, like all these things you have described. And then failure criteria while designing a machine element, what are the difficulties and then factors that we have to see and analyze in designing. Those are the parameters you have given, and about the material strength and stability, how the material is, the nature of material, and then all these things we have discussed. And then basic procedure of design. So we have given a flow chart for the design of machine element. In that, you have given specify the functions of the element. So
Yeah.
what the element is going to act upon. First, that we have to decide, and then what are the forces involved in that function, and acting upon that. Next to that, and we go for the suitable material for the element, whether it has to be flexible or ductile or malleable or brittle or anything, depend upon the need of the hour. And then we have to go for the failure, determine the failure mode of element, and we have to do various testing for that element material. And then geometric dimension, in what shape, size, dimensions, and all these kind of things involved in that. And then go for the assembly and manufacture. So this goes for the post step of the mathematical design procedure. So finally, we are giving a pictorial model for that element. After that, we have to go for the production of that material. So also we have seen a design of a key. A key is a thing, a small thing which is used to connect the shaft with the motor side and then the another rotating side. So which is used to transmit the power from the motor to the rotary equipment. And we have seen how it is designed, all the formulae and design procedures of designing a key. And that's all we have seen today. Is that okay, sir?
Good,
Hello.
good. Yeah, good information, John. Rishi, you are in
Thank
which
you, sir.
college or which year you are and your branch?
Sir, basically, I'm a 2019 passed out batch,
Ah,
petrochemical technology from Tiruchi Anna University, Tamil Nadu.
okay,
Currently, process engineer at Kempla Sanmar.
okay. Yeah, good,
Okay.
good.
Thank you, sir.
So, are you getting the since last couple of days you have started this course? So you are getting the good inputs from our experts.
Yes, sir,
Yeah,
definitely.
yeah,
Because all these years, in the 4 years, I have been studying theoretical parts and all that. And in the 1 year of industrial experience, I have also gained so much of information. And with this internship program also, I have gained some knowledge on how oil and gas sector is actually is, because I haven't entered the oil and gas sector since now. So that was a very good brainstorming sessions.
yeah. Good, good. It is a good learning by you all also. You are very patiently heard the lecture. You are given the good inputs, and definitely it will help to build your career. Although you have completed a couple of years in the industry, and you have to go ahead in future career also. And we all, intern expert, we hope for your better future, better career, and better prospects. Okay, and
Thank you, sir.
yeah. With this, I will conclude today's session here. Okay. So I will conclude today's session here. Thank you all. Thank you.
Thank you, sir.
Yeah, welcome.